Now, good day, viewers. We are continuing with the systematic naming one. Today, we'll be looking at another interesting side of it. We are trying to learn the two at a go. Now, in my previous video, I made mention of whenever we are calculating with we want to write the systematic name of two compounds, just like that. We'll find the oxidation number for the first element. Now, whenever the compound consists of three different atoms, now we'll find the oxidation number for the middle element. Now, let's look at. I have H2 carbonate. So H2 carbonate. How do I write this one systematically, or IUPAC naming? Now, I said that. Okay, let's count the atoms here. We have hydrogen, carbon, and oxygen. So we'll find the oxidation number for what? Carbon. Now, what is the charge of hydrogen? It is 1. Now, what is the molecule of hydrogen here? It is 2. Now, we are going to use C to represent carbon. Very good. Now, what is the charge of oxygen? It's -2. It has a molecule of what? 3. So the total oxidation number of a compound like this is 0. We made mention, we said this in my previous video. Now, 1 times 2 is 2 plus C. Now, when this one -2 and 3 multiplies, we get -6. This one should give us 0. So when I group like, I'm going to get C minus 6 plus 2 is equal to 0. So C here will give us -4 is equal to 0. So C here is what? Plus 4. So that is the oxidation number of carbon. It's plus 4. Good. Now, how do I write this one systematically? So the first way is that I will say hydrogen, because hydrogen is the first thing over there. So hydrogen, then I'll go straight to the molecule. So hydrogen tri, then the next one is ozo. The ozo there is oxygen. Then the whole thing there is carbonate. So carbonate. So hydrogen triozocarbonate. Then what you calculated for will come. It will come in the form of a Roman numeral. So IV is equal to 4. Now we can write it this way, or you see, in science, anytime the compound starts with H, that compound is an acid. So that compound is an acid. So the same thing, when another person writes it this way, the person is right. When another person also write the second way, the person is right. The second way, we are not going to start with hydrogen. We are just going to start with the molecule of oxygen. So we say triozocarbonate, then the carbonate 4 acid. So these are the, anytime you are calculating or you want to write systematic naming involving hydrogen, hydrogen being the first element, it means that very compound is an acid. Very good. So these are the ways that you can write them successfully. Okay, let's look at another one. I have is a krypton. Okay, so I want to write the systematic name for potassium chromate. How do I do that? So I'll first of all find the oxidation number. Then from here I can successfully write the systematic naming. Now, what is the charge of potassium? It is 1 plus 1. It has a molecule of 2. We just write it. Now remember, in my previous video, I'm saying that anytime what we are looking for is having a molecule, it is taken as an atom. So this one becomes 2Cr. The Cr is what? The chromate. What we are looking for. I believe it's clear. Now, what is the charge of oxygen? Is -2. The molecule here is 7. Is equal to 0. Okay, so we are having 1 times 2 is 2 plus 2Cr. Then -2 times 7 will give us -14. This should give us what? 0. So we need to group like terms here. So 2Cr minus -14 plus 2 is equal to 0. So whenever they react, I'll get 2CR, then -12 is equal to 0. So grouping of like term, 2CR is equal to 12. Now making CR the subject, divide here by 2 and I'll divide here by 2. So I'm getting CR to be what? Plus what? 6. Plus 6. So we have to pass through all this to get it. Now how do I write it? How do I write it? Now in writing this, we are going to start with the metal and say that this is potassium. This is potassium. So potassium, because of K, so potassium. Then we go back to the molecule. The molecule there is 7. So 7 is hepta. So potassium hepta oxo. Potassium hepta oxo. Potassium hepta oxo. Now the 2 here, the CR here is 2. So therefore we need to write it the way it is. So it tends to die. So potassium hepta oxo die. Don't forget, dichromate. So dichromate 6. Just put it in a bracket. So this is potassium heptaoxo dichromate 6. Now it's getting more interesting, yeah, because science is very interesting act, very, very, very important. We need to know all this to make the things very, very simple for us. So this is the way we write potassium chromate. The systematic naming is potassium heptaoxo dichromate 6. Now let's again look at another baffling one. So that one is Ca into brackets. Good. Okay, so this is what we are looking for. It says we have potassium, then we have hydrogen, then PO4. Again, let us concentrate in the one in the bracket. So what do? We find the oxidation number for the P in the bracket. So what is the oxidation number for potassium? What is the charge of potassium? Calcium. Calcium is what? 2 plus. Now remember binomials. Whenever I have A into bracket B plus C, the A multiply the ones in the bracket to give us what we have. So we are going to obey the same rule here. So the 2 here is going to multiply whatever we have here. So what is the charge of hydrogen? Hydrogen is 1. It has a molecule of what? 2. Remember the 2 outside there is also multiplying, so we're having a 2 over there like this. So we write our plus. Very, very simple. Now we are looking for P. So the 2 multiplies P to give us what? 2P. Is that clear? Good. Now what is the charge of oxygen? It is negative what? 2. The molecule here is 4. The molecule there is 4. But remember, it is multiplying these 2 over here. And this is equal to 0. This is equal to 0. So let's try and then. So this is 2 plus 1 times 2 times 2 will give us what? 4. Then we come to plus 2P. Now negative 2 times 4 will give us negative 8. Negative 8 times 2 will give us what? Negative what? 16 is equal to what? 0. I guess you are following. Good. Now let us group like terms. 2 plus 4 here will give us what? 6. So plus what? 2p minus 16 is equal to 0. Now when we group like terms, we are going to have 2p minus 16 plus 6 is equal to 0. Now, still grouping of like terms, we are going to get 2p is equal to negative 10 is equal to 0. Now, 2p here is equal to 10. So when I divide here by 2 and divide here by 2, we say p here is equal to what? 5. So we've found oxidation number for p, and that is 5. And 5 in Roman numerals will give us what? 20. So 20 there is 5. Now let's continue and then find, so it's positive, so plus 5. Let's move on and find its systematic name. So how do I write this one? So I'll say calcium. So calcium is the first thing. Good. Now when we go inside the bracket, you see that hydrogen is there, but hydrogen is having a molecule of 2. So like the first one we did. So calcium, because it's having a molecule of 2, we say dihydrogen. So calcium dihydrogen. Then we start by saying that tetraozo. Then the whole thing here will give us what? Our phosphate. Then what is our, this thing is 5, so we put our 5 there. So simple. So calcium into bracket, hydrogen phosphate, written as a systematic name, we will be getting calcium dihydrogen tetraozosulfate 5. Now this is Gatology Online, maths and science. You like, you follow, you like, you share to others to be blessed. Bye bye.